And of course, now we want to understand how we can implement a basic singly linked list. A singly linked list is simply a type of a linked list. So if we understand how we can implement a singly linked list, then it will be way easy now to implement the other types of linked list that we'll talk about as we proceed in this session or in the next session, which will be of course the final session when it comes to the linked list. So in defining a singly linked list, we can define it as simply a data structure that is made up of nodes, and of course those nodes, they are created using self-referential structure. Like you can tell from our structure here, this is more like a singly linked list because it is being created using a referential. Now you can of course intel that we've created now a head as a data structure that is based on the pointers, because of course linked lists are highly based on pointers. Now you can tell that this variable, of course, which is based on the pointers, is designed in order to hold the memory address for the very first node of this linked list. Hence it will keep 340. And the very first node, since it contains two parts, the first part to hold the data and the second part to hold the link to the next node, we can now intel that it will of course hold on the memory address for the second node of the linked list, which is 546. We are using the numbers because we understand that it will be more complex if we were to be using now the actual naming notations that are used in order for we to identify the memory address that each and every node is being safe kept at, because hexadecimals are now involved in such issue. And again, you can tell that the second node of this linked list will now keep the memory address for the last node of this linked list. Hence we'll keep now a 253 as the memory address for the last node. And the last node, since it is not connected to any node, then we expect the actual link that should hold the link for the next, or the that should hold the memory address for the next node to be declared to null, since we are terminating the process as it is not connected to any node. Hence we'll keep a 0 inside, and whenever you see 0, you can intel that yes, it is a null value. So let's now proceed on to how we can implement a linked list, a basic linked list. Don't forget, as we proceed with our session now practically, how can we implement a linked list? Well, the very first thing that we need as we want to implement a linked list, we need to declare a node, or to make a structure that would define the actual node and how it should look for the entire linked list. Like we were saying, a linked list is simply made up of a node which contains two parts. You can now tell from this code that we have on our screen that yes, we are now making a node that contains two parts. Hence the keyword struct simply entails that it is a structure. Don't forget, we are doing data structures. Hence it is a data structure which will be called a node, since we are making a node, and this node contains two parts. The first part is made up of a simple data type, which is int, an integer, hence whole numbers, and the actual name for this variable is called data. And another part of a linked list is made up of a pointer variable, and you can tell here that yes, we are making a pointer because node plus that asterisk simply entails that we are creating a pointer, and this variable will be called next. So here definitely what we are saying is this one will keep data and this one will keep a link to the next node, because pointers keep memory addresses of related or of any functional variables that we might want to keep inside that variable. And of course here we have a semicolon, meaning we are terminating this structure. We have made the structure for the node, we have declared the node. Now what does this line now of code entail, or what does this line mean? Well, don't forget, we said each and every linked list should have a head, and the head should keep the memory address for the first node. Hence what we were saying is, since we should have a head keeping the memory address of the first node, then it should also be based on a pointer as a data type, since it will keep the memory address. So at start, we've created, of course, head as a variable, and which is based on a pointer. And since at start we've not yet implemented any node which should keep the data and the like, because this is simply the structure of that node that we will create, then we have by default initialized head to now. If we initialize head to now, then it means we are saying head isn't pointing to any link, isn't holding any memory address for any node so far, which is fine because this is what we are actually doing. And from the code you can entail when we go on our IDE, which is of course dev C++, the one that we installed. And if you've not installed this IDE and if you wish to download this entire code, please check the description below and you'll find a link that will lead you to the right platform where you need to start from. So you can entail that this is what we've implemented even in our IDE struct, which is the normal structure, and we're making a node. This node contains two parts. First, the variable that will hold on to any value of a simple data type called int, which is integer. And the next thing that we've done is we've created, of course, here a pointer variable which is next, because it will be keeping the memory address for the next node. And by default we've of course also implemented a global variable like I have said, which is also based on a pointer variable, and the name of that variable is called head. By default it is initialized to now because it is not yet keeping any memory address for anything that is related to any node so far. And it is a global variable because we want this line of code to be always be used by any function that we implement under this thing, hence making it a global variable, like the keyword global, meaning it can be accessed by anyone. Let's proceed on our theoretical understanding and see what we have done and how we can implement a basic syntax of a linked list. So there are some operations that we need to perform on a linked list. We need to insert data, we need to delete data, we need to update, and anything related to that. But on our basic understanding of a linked list, we just want to understand few things. And the very first thing we want to understand is how can we insert data into a linked list. So this is what we are discussing here, how to insert data into a linked list. And we have created, of course, a void function. If you understand functions from the introduction to C++, the course that we have on our platform, which is coordinate, then you can entail that this function shouldn't return any value. It isn't a returning value type of function. And the function name is called insert. And we've of course added a parameter which should accept a certain value coming maybe from the main function or from any function, which is int value. So this value is actually the number that we'll be getting. It could be a number, it could be multiple numbers that we'll be getting time by time in order for we to add content inside this linked list. So you can entail that we've created another variable which is another node, or we can say another new node, or should I say the very first node of this linked list, which is of course also based on a pointer. And this is a keyword when it comes to data structures in C++. This is a keyword new node, and of course you open the parenthesis and of course you end now with a semicolon. This is a keyword, and what it means is it is giving us now the chance to create a new node which is based on the structure that we talked about, which is this structure. So new node, and of course you open and close the parenthesis, is simply making a new node which has two values or two sections of it. The section to hold the data and the section to hold the next as a pointer variable, like we declared from the actual structure that we implemented previously on how this linked list should look like. So here we are now saying, okay, the very first content that should be inside this variable, which is the variable we declared, which is based on a pointer, which is now pointing to data. We are pointing to data because we know that on the structure for a linked list we specified data as something that should be inside this linked list on any node that has been created. And this key thing is simply an operator. It is an operator that allows us to actually access any element of any data structure. It is an operator. Please get me clearly and vividly. It is an operator, and when writing it, we simply write an underscore and a greater than sign. Then you've implemented that operator, which allows you to select a specific element that you want to work on. And here we are just saying, okay, another node, which is, of course, we understand a variable based on a pointer, a newly created variable, which should point now to data, is equal to the value that we receive in this insert as a function. And of course, now don't forget the variable, which is the content that should be on the position from the structure we made at the position of next, should be equal to head. What we are saying is head should be equivalent to the next as a variable, and anything related to that. Head should be assigned to next, to the content that should be at first as a link to the next variable. But the very key thing that I want we to understand is this thing that's happening here, because we said head is simply a variable that should keep track of the memory address of the next or of the very first node that will be created. And this is what we are saying. Head is equal to another node. If we have head here and another node, which is of course the very first so far, the very first node that we've implemented, if it is at the memory address 22x5, this line of code just entails that, okay, so head will keep track of 2x5 because head should keep track of the memory address of the very first node. And you can entail, if we are now to put in another value inside this insert function, then automatically we are inserting the function from the beginning. Hence, the very first node will move on the next side, and the newly inserted function will be here. And this will link now to the next node, and head will point on the newly created variable, or should on the newly, and head will point on the newly created node. If we are to insert another node, then we will implement another node which should come before head, and head will always point to the newly created node. And this is what we've done also in our IDE. We'll run the code for you to understand what's happening. We have implemented the insert function int value as a parameter that's coming in, and we've of course created a pointer type variable which is called another node, and this is equal to new node. New node, don't forget, is simply a keyword in C++ or in data structures, which actually allows you to create a new node based on the syntax that you specified from the struct as a structure of the node that you implemented. And another node should point, of course, to data, and the value should be equal to that. Another node next should be equal to head, because we understand that so far head is equal to now, hence that will work out well. And currently we want to change the value for head. Head should now point to another node. If it points to another node, then clearly we understand that head will keep track of the very first link or of the very first memory address of our very first or of our very latest node of this linked list. And automatically here we can now understand on how these things are happening when we come now to the display function. Display is simply another key function of a linked list. How many values are inside our linked list? Automatically we also need to understand, okay, how can we visit each and every node of a linked list? Imagine you have a linked list with thousands of nodes, keeping track, of course, as in a chain format. The first node, data, link to the next node, second node, data, and link to the third node, keeping track of such information. And imagine you want to display the whole data. How can we now move across each and every node? So in here we understand that, okay, to display that, we've created a newly implemented now temp variable which is based on a pointer, because this is what that means, and struct just entails that we are working with data structure and anything related to that. And we are saying now temp is equal to head. Don't forget, we said head should always point to the very first memory address of our first node. Else we can't visit each and every node using head as a pointer variable. No, because when we do that, automatically we'll destroy the format for head, and automatically we'll disturb head, and finally the linked list will be destroyed. So we need to have a different type of variable which is based on a pointer variable, because that's what head is based on too, which is the variable that we will use in order for we to travel across or to travel through each and every node of our linked list. And this is why we are saying we've implemented a while loop. This while loop will allow us now to traverse, or should I say to travel through, or should I say to travel across each and every node. So we are saying wow the temp is not equal to now, because we understand that if the temp is equal to now, then it means the linked list has been terminated, because now we will simply terminate the linked list, which is of course 0. So we are saying wow temp is not equal to now. Please see out temp, which is of course now using the operator that allows us to select. Please use the temp variable to select only the data of that linked list, and you end the line. And if it is not equal to now, then please proceed also to the next node and give us the content that is at temp of the next node. We are more like advancing the linked list slow by slow in order for we to proceed with the iterations. So if this evaluates to true, this will come back and happen again. If this works, then this will come back and happen again. If this process works until we reach the point where we will understand that okay, temp next is equal to now, then of course it will terminate and the process on continue. If we come back on our IDE, this is what we've implemented, the actual things on our display function. Display void, of course not returning in type, and we've created a temp pointer based variable, and we are saying temp is equal to head because we don't want to disturb head. The head should always point to the very first node, and we've implemented a while loop. If you don't know actually how to implement a while loop, please check the description below. It will lead you to the video that will help you to understand how a while loop is and how it works here on CodeNet. Don't even forget to subscribe. And definitely we are saying temp should not equal to now. As it is not equal to now, temp data should be seen out, and temp should continue the iteration until it reaches now. This is what this thing actually entails. So this is it. And finally, let's now understand what is in the main function now. The main function will actually drive the entire process. It's more like the driving content of this entire linked list. Hence, we'll see that on our IDE, we've implemented the main function and we are calling the insert function. You can tell insert 56, it is the number that is being sent on the very top parameter that is on the insert function, which is value. So once the value is inserted, that will go into that node. Insert 90, that will go into, of course, a linked list, because the node we've already implemented in that function, hence it will continue making the node. Hence you can even count at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10, of course, nodes of this linked list. And down here we are just saying okay, this is simply we are just saying okay, see out that, and of course see out this just creates a new line for we not to leave some space between this asterisk and this asterisk, because we are just designing now. The values inside the linked list we are calling the display function. So when we call the display function, automatically the all content that has been sent into the insert function will now be printed out. So here we now want to process the head. We want to understand how the head actually works. So we are saying okay, see out that, of course, this of course from 58 to 62, you understand that we are just doing the design. It has nothing to do with the mathematical understanding of how this code is working and anything related to that. So here on line 64, we are just saying, okay, head points to this address, and automatically when we approach head as a pointer variable with, of course, the operator pointing to next, we should see the actual address of the very first node that is next to head. Of course, the node that is last to be added into that linked list, because we are adding from the beginning. And finally here we are saying, okay, value inside head is, of course, head towards data, meaning we will display now the data that is at that respective memory address where head is pointing, which is of course the last node, the last data in the last node to be added into a linked list, since it will replace the node that will be next to head. Hence now the very last content, it's the content that will be next to head, or it is of course the node that will be next to head. So let's Control S, compile and run. We see how this actually works. So when we compile and run, we need to see all the values that we've sent to head, and of course we also need to see the memory address that head is holding to and anything related to that. Let me now, okay, so we are saying, okay, the values inside the linked list are such, of course, which we've said, and processing head points to the memory address of, so this memory address is the memory address for this as the very first value that is on the node which is next to head, and automatically we are saying, and the value inside head is 897, because it's a value that is next to the variable where head is actually pointing at. So this is how you can now automatically traverse a linked list. And immediately you traverse a linked list, please, you can download this code on the description below. Immediately you traverse a linked list, then it means, yeah, you are ready to go, and we are at least active, because we now understand how linked lists work and how we can implement them. So let's proceed now on our next session as we understand now the actual or the very stable way of implementing linked list on an intermediate level. We'll add more operations, and we'll of course make a menu driven code which you see, which you understand in order for we to implement a linked list. Please don't forget to subscribe, and you are on CodeNet.